So serverless architecture has become really popular in recent days, and in this video we are going to learn everything there is to know about serverless architecture. So without any delay, let's get started. So you must be seeing that I am slightly faded, and now you are going to be seeing me going completely pitch black. And the reason it happened is because I simply turned off my lights. Now you must be wondering, what does light has to do anything with the serverless? And there is a very clear metaphor that we can think about. Think about a simple scenario that typically we are surrounded by electrical equipments. We are surrounded by electricity. We all consume electricity, but we don't know how to generate electricity. We don't know what electron protons work. How does the electricity transportation work? We don't care about it. We simply pay a certain amount of money in order to consume electricity. This is the same logic applies to the serverless architecture, where you only worry about the piece of code that you are writing. You don't care about that where that piece of code is going to run, how the server is going to manage. Everything has been taken care by the amazing companies who provide cloud services. And they have come up with the concept of serverless computing, where from the name it seems like there is no server associated with that. But it's not possible. We need electricity to run our lights. Same thing is applied to the serverless code, where the companies are just saying that why don't you just go ahead and provide us with the piece of code. We are going to make sure that whenever that code needs to run, that you decide, we are going to have it available and have servers available in order for you to run it. So same way, we don't care about the infrastructure behind electricity. We also don't need to worry about the infrastructure behind our code or piece of solution running. Now, the good thing about it is that just like electricity, we don't care that how much electricity goes through my entire house. I'm only being charged for the amount of electricity I personally use when my devices are on. Same way, for the serverless architecture, the companies came up with something else. They came up with a micro billing concept, where the only thing they are saying is that rather than charging you for the entire server that is always going to be available to you, we are going to take care of the server. And we are only going to charge you for the number of transactions you make throughout our servers. And this is another logic in which, now imagine that what are the benefits being offered to you as a developer. Number one, you don't have to worry about what type of server it is going to be. The server is available for you, so that worry is gone. Number two, you don't have to worry about paying for server to be up and running all the time. They are guaranteeing you that you only pay for the number of transactions that happen. If the number of transactions are just one, you only pay for one transaction. If the number of transactions are 1 million a day, you pay for the 1 million transactions. If, say for an example, the number of transactions suddenly grows large. So right now you are being called only 5 times and suddenly immediately you are being called by like 500,000 people. Then also they are guaranteeing that they would be able to take care of all the load, all the servers, all the scalability, availability, all of those beautiful utilities that we really like in system design. Now the question is serverless the best opportunity, and why don't we all just simply use serverless and don't use anything else? The thing is, many times we need our applications to be up and running 24/7, and we don't need to rely upon someone else just running the services. So it's not like that microservice architecture, or in some cases like on-premise architecture, is going to go away and everything is going to become serverless. That is not feasible, because many times in order to establish that first transaction or first trigger, that needs a cold start, because currently your services are not up and running. So the very first moment when that event happens, when the server needs to run, a call needs to go through from the origin to whatever the service, AWS Lambda or Azure functions, Google Cloud functions, IBM functions, no matter what they are, there needs to be a call that goes through. Immediately the servers realize that now I need to process these transactions that are coming in. Let me allocate some resources, or let me have this piece of code run somewhere so that all of these transactions can go through. So number one issue is there could be potential cold start problem. So that is number one drawback. Number two drawback is you are very tightly deadlocked with the choice of the vendor you currently have. Because right now you are feeling so awesome that, hey, as a developer, I just write down the piece of code and then I just gave it to Microsoft Azure and told them that, hey, whatever happens, keep running this code. Anyone in the world calls and you do your thing. And I'm going to focus on eating popcorn. But the thing is, that is a very same tactic that all the cloud companies want, because now you are completely stuck and vendor locked. And if the trade-offs are not balancing in one way or the other, you might be stuck with Microsoft even after realizing that AWS can do the same thing for like half of the price. But now you are so tightly coupled, you cannot do anything. So these are some of the benefits, and there are some of the drawbacks of both a serverless architecture. Now let's try to understand some of the very important services that serverless computing has to offer. So number one service is a function as a service, where it's just a combination of, or the summary of what I just mentioned, that you are providing your piece of code or your function that, hey, this is the task I want to be completed. That task can be anything. That task can be that, hey, if someone comes up to you with this specific API and tells you I want A plus B, you just do the sum of these two values and return back the value. It can be as simple as that. It can be as complicated as is someone tells you that, hey, this is the amount and this is the account number I want the money to be sent out. Then also you need a piece of code to execute all of that query and then speak to that other bank and then speak to the third party agent and then update all the databases and manage all the asset properties and come back and give the confirmation that your money has been transferred. This can also be done through serverless, and doing the sum of two values can also be done through serverless. The only thing you don't care about is the underlying server that you have to worry about. Okay. Now, second option or second service that serverless has to offer is called backend as a service. Backend as a service provider offers a suite of cloud services and APIs that can replace the traditional backend servers for handling all of the operations that we typically do. So operations such as like database operations, authentication operations, file storage, file transfer, and bunch of other things. So all of these things for which previously we have to write specific codes, we have to make sure that that code needs to execute somewhere, there needs to be some secure query for that, there needs to be encryption, authentication, authorization. Now we don't need to worry about all of these things. These are the services that the cloud companies or the serverless functionality is already providing us. All we need to do is just configure or connect two values. So these are the two main functionalities that are being provided by serverless architecture. Number one is function as a service. Number two, backend as a service. Things like data management, authentication, security, cloud storage, event-driven architecture. And for event-driven architecture, there are a bunch of different events that could happen. So number one event could be some trigger that is happening. Number two event could be some time-based event. Number three event could be that there are some operations that are being done. Once those operations are completed, execute these events. So all of these things are also part of the serverless service. Now, how does the security model works in a serverless scenario is that there is a huge focus on shared responsibility for the security. And who this responsibility is shared between? Well, there are mainly two parties. So number one party is your AWS, Azure, or your Google Cloud Platform. So basically the cloud provider. They are saying that we are making sure that your call is going or your transactions are going to be secured in the matter of number of resources, number of servers, number of CPUs, the networking bandwidth, and of course they are going to charge you for that, but they are taking all of these guarantees that it is always going to be there, maybe even disaster recovery, availability zones, all of these things. But then there comes the second party who needs to be responsible for all the transactions that are actually coming in to the application. And that's where you or the suite of developers who are developing or working on that product comes into the place. You need to make sure that you are taking the responsibility for the security of application layer. So this becomes that number one, who is able to call your services. Number two, are the incoming calls secure? Whatever the data you are storing, is it encrypted or not? If you're talking between two parties, how that communication happens? Which are the resources that have access to your network or your transactions to come in? Is there the practice for authorization and authentication followed completely? So all of these things you need to be responsible for. So let's try to understand some of the best practices for the serverless application in terms of security. So number one item is the least privilege model. And this is not only true for serverless, this is true for any system that you are trying to build. You need to make sure that there are minimal permissions assigned for your function to interact with other resources. You don't grant every single access to every single resource in order to interact with each other. It is going to be really easy to implement, but it is going to open you for so much vulnerability and so many attacks. So make sure that the amount of privilege, that can be anything, privilege given to human, privilege given to different parties to speak with your application, that has to be at the minimum or least privilege access model. Second thing is, you need to make sure that you secure your application using many different secrets. So all the sensitive information like passwords or API keys, client ID, they all needs to be, number one, encrypted, number two, securely stored in like some key vault, that can be Azure Key Vault or HashiCorp Key Vault or some other place. You don't want to hard code all of these values. So that can be second piece of security that you need to make sure that you are responsible for. Third is the input validation. So you never wants to expect that all the incoming traffic that is coming into your server, that is always going to be good and valid. What if you have a function that does the sum of two values, and then someone comes in with an API call, and instead of providing you two integer values, they provide you both like string values or null values or some SQL injection query attack, something like that. And if your code is not defensive, there can be some bad things that can happen to your database. They can gain access to your database. They can simply feed in bad information to your application, things like that. So you always want to make sure that you are validating the incoming request. You have put in the reasonable checks and balances in place. Next is dependency management. So your piece of code or your software, if that is dependent on some other third-party libraries, third-party version, you want to make sure that you are updating those libraries. You are making sure that they are up to date. There are no pre-existing vulnerabilities. And that's where frequent and regular security scans come into the place. So things like tools like Veracode or GitHub Advanced Security, or there are a bunch of different other tools that does security scanning on your piece of code. So you can do those static scan analysis, and you can also make them part of your DevOps pipeline or your CI/CD. So this is going to be really important in order to mitigate a lot of the things that you can secure on your end. And after understanding the best practices for security, let's try to also understand that what are the common security threats that can come towards your way. So I already mentioned about the injection attacks. This is where someone is trying to inject bad queries or bad data to your services. So you need to take care of securing that. Second, your infrastructure that is currently up and running, how can you make that secure? So infrastructure in terms of you must be saying that, hey, why do I need to worry about infrastructure? Aren't the cloud providers taking care of all the infrastructure responsibility? And you are absolutely correct. They are taking care of all of those responsibilities, but you also need to make sure that you are providing correct data, that this piece of code needs to run on like a node server with this much CPU, with this much memory, with this type of pricing plan, and with this many resources. You need to decide that. And no one can remember all of these things. So that's why I would highly recommend you to have some sort of infrastructure as a code pipeline, part of your pipeline. So if something goes wrong, you can always bring those services up and running very quickly. Next is DDoS attack. So DDoS attack is a very common type of attack where some third party bad actor tries to flood your services with lot of calls, and then suddenly your servers they either are not able to handle the load, or if in the case of serverless, your number of transactions increases many more than what your actual traffic is, and you end up paying much more money. So in order to update that, you can have security functionality like rate limiting and alerting and alert detection and anomaly detection in your services. So these are some of the best security practices that everyone should follow in general for most of the system design, and they are also very true for the serverless architecture as well. Number one problem with the serverless architecture is that the cold start problem. That let's assume that no one is calling your functions, which means they are not currently allocated to any of the servers. They are sitting idle, and when someone shoots a query or makes a call, immediately your server needs to start up and running, and that takes time in between. There is some latency. So in order to resolve that, you can either have like a regular service that just keeps on sending out some of the transactions at every frequent regular intervals. So your systems are not completely idle, and you can even set things like make a call every 5 minutes or every 10 minutes. That is not going to increase your cost significantly, but it is going to really help you with the cold start problem. Second thing is you can try to opt for higher plans, but that is going to increase your cost exponentially. So that decision you will have to think with your team and your specific scenario, that do I really needs to do that or not. Next is resource allocation. So for that, I would highly recommend you to keep checking that what type of resources are actually good for you. You don't want to be in a position to have a super computer just to play the game Snake. You actually wants to have a balance in between your requirements and also the efficiency it serves. So always try to have that discussion with your team. And there are awesome tools that are being provided by all the cloud providers. So things like good tools for like monitoring and analysis. Second, they also provide you very good cloud metrics, the number of transactions that goes through, how expensive they are, what has been the CPU utilization, alerting and notification and centralized logging and app insights and all of these cool things. So make sure that you are after building or deploying the application, you are also constantly monitoring your serverless architecture in order to make sure that are they good and efficient and robust or not. Okay, so this brings us to the end of our discussion about the theoretical portion of what serverless architecture is. Now let me give you a very small, very quick demo on how actually serverless architecture work on Azure Functions. Okay, so currently we are in the Azure portal. So let's create first of all a resource for the function app. So we can see the function app resource over here. We are going to select subscription as pay as you go, and we are going to select the resource group as function app demo. Now let's just name the function app. Now this name has to be unique. So we will try to select the name as Destination FAANG. Okay, I think I wrote the wrong spelling, but it doesn't matter. Now I want to deploy the code, not the container image, because I don't have any image available at the moment. As a runtime stack, I'm going to select Node.js. I can select the latest version, and as a region, let's select Canada Central. So, or Canada East, that is good. I'm leaving this as Windows for the operating system, and for the hosting option, I'm selecting the consumption model or the serverless model that is specifically designed for event-driven workloads. And let's quickly review and create, and let's create this one. So after the deployment has been completed, we should have our function app ready. Okay, so looks like the deployment has been completed. Let's just go to our resource. So now since we don't have any functions, let's create a function. Now in the create function, we have given a bunch of different options. So first let's see the development environment, and we are just going to make something very simple. So we are just going to develop in the portal, and as part of the trigger, we are keeping an HTTP trigger. So with an HTTP call, the function will get triggered. But if you see over here, there are a bunch of different options in order for us to select various different triggers. And this is the actual benefit of serverless, where you can select on your own on how you want your function to be run. Now for our function, let's just quickly give it a name. So we are going to give the name hello world to keep it simple. And next one is the authorization level. So who has the access to the function? Now for the simplicity, I'm just keeping it as anonymous, but you will actually have some more fine-tuned control. And now let's just quickly create the function. So looks like our hello world function has been created. And now let's just go to the code and test. Okay, so this is the piece of code that is actually going to run. So let's try to make some changes to the code. Okay, now let's try to just simply print hello world in this our code, and let's try to save the code. Now let's see that how does this code run. So we will get the function URL, we will copy the URL and we will try to paste it, and we can see that it is giving us the hello world from Azure Functions. Now you see how simple this was. We don't have to put any more resources in order to take care of the infrastructure or where the code is going to run. We simply just put everything in the API, and we can, if when we do make the call, we can see the function running as expected. So you can have all sorts of different functions and different functionalities that can complete the task that you want. And you also have a lot of options for various different integrations and monitoring and private keys and function keys and stuff like that. But we are not going deeper into that. So this was the full explanation related to serverless architecture. I hope after this video you at least had the more than basic idea about what serverless architecture is, under what scenarios you should use it, and what are the pros and cons of using serverless architecture. Let me know in the comments, what do you think about this video? Do you think is there any way I can make it better or include more information or maybe try to do more elaborate demos or whatnot? I'm trying to improve the content and your feedback is really helpful. So till then, take care.